Okay, so you've learned how to solve systems graphically and then understand that the solution is an intersection. So now we're going to solve algebraically, which is really preferable given the limitations of graphing by hand. If you have technology, that's great. Anyway, we're going to learn the substitution method when that's useful, and we're going to learn the elimination method and when that's useful. And you'll have to do one word problem. You will be doing numbers 1 through 23 odd. So I'll do a couple of the evens. Number 2 is x plus 3y equals 3, and 2x. Actually, I like to write them side by side. You'll see why in a minute. And 2x minus 4y equals 6. Well, if I'm going to substitute, I want one of the variables by itself. So in this case, if you look at both equations, x is already alone. So if I subtract 3y from both sides, I get x equals 3 minus 3y. So I have just written x in terms of y. So now if I plug that in for x, I will only have one variable. So now I can write 2 times 3 minus 3y minus 4y equals 6. Do some distributing. Do some simplifying. 6 minus 10y equals 6. Subtract 6 from both sides. Y must equal 0. Well, now if y equals 0, now I go plug that back up in here, and I'll see that x equals 3. So my solution, remember this intersection is a point, is 3 comma 0. And that should work in both equations. 3 plus 3 times 0 equals 3. That checks. 2 times 3 is 6, minus 4 times 0 is 6. That checks. In some cases, you might see, for example, the idea is to find which variable is by itself. So, for example, number 4, 2x minus 3y equals 3, and negative 2x plus y equals negative 4. Which equation would you use to get x or y by itself? Well, when I look, I don't want to use this one. Here I see y by itself. So I'd add 2x to both sides. I like to have the positive term first, so I'm going to write it as 2x minus 4. And then again, you're going to plug that into there. Now everything will be in terms of x. You'll solve for x. Once you find x, you plug it back in here and find y, and you'll find a point, x comma y. And again, that's the intersection. So that's the substitution method. Most of you are probably familiar with that. So what about the elimination method? If you don't have a variable already by itself, the elimination method is the way to go. I like to liken it to what skis might you use. If you look up and see a giant slalom course, you're going to use your giant slalom skis. So I'll do number 8, and that looks like this. Now in this case, I am going to write them vertically over each other, because the idea behind elimination is I add or subtract depending on the situation. I want to eliminate one of the variables, and I can see that if I add these two, the y's are opposite signs and they will eliminate. So I'm going to add this equation. 5 plus 2x is 7x, and negative y plus a positive y eliminates, and negative 9 plus 2 is 7. Divide both sides by 7, x equals 1. Now the bonus of the elimination method is you often get to the first variable a little bit quicker, but then when you plug it back in, and you can choose either equation, 5 times 1 minus y equals negative 9. Actually, this one's probably a little easier to use. 2 times 1 plus y equals 2. And again, we can see that y is going to have to be 0. And so my solution is 1 comma 0. That can't be right. 2 times 1 plus y is 2. 5 minus 2 is not negative 9.